Press the bell icon on the YouTube app and never miss another update.
Find the values of a and b so that the function f of x is continuous. This is the question. Okay, first take the real line. 2 is there and 10 number is there. X less than or equal to 2 is there, that's why we are taking the closed interval. In this area it is the constant, means 5. Next 2 to 10. 2 to 10 means just deleted neighborhood of 2 and less than 10. In this area it is defined as ax plus b, and when x greater than or equal to 10 it is defined as constant, means 21. So this is the given this is the given function. Okay, breaking points are 2 and 10. So clearly breaking points x equal to 2 and x equal to 10. It is indirectly given that f of x is continuous at x equal to 2 and at x equal to 10. So case 1. Suppose f of x is continuous at x equal to 2. That implies, or by implies, limit x tends to 2 minus, I will try to take the direct step here, is equal to limit x tends to 2 plus f of x, it is also equal to f of 2. So that by implies x tends to 2 minus means it is nothing but x less than 2. This is x less than 2. This one is x greater than 2. X less than 2 means this area, it is the constant. So we can write directly 5, or okay, we follow the procedure. It is nothing but h tends to 0, f of 2 minus h, that is equal to limit h tends to 0, f of 2 plus h also equal to f of 2. Actually here in this area, less than 2 area, f of x equal to 5. F of x equal to 5 means it is a constant function. So what about f of 2 minus h? Same, 5, because it is a constant. So that by implies it is directly 5, that is equal to x greater than 2. X greater than 2 means this area. So limit h tends to 0. Function is ax plus b. X means 2 plus h plus b. So that is equal to f of 2. F of 2 means is equal to 2 cases here. Therefore in this case f of x is defined as constant 5. So that is equal to 5. So that by implies 5 is equal, means limit h tends to 0 means a into 2 plus h 0 plus b equal to 5. So that by implies 2a 2a plus b equal to 5. 2a plus b equal to 5. Let it be equation number 1. Next, next, case 2, case 2, case 2, case 2. Suppose f of x is continuous at x equal to 10, at x equal to 10. So therefore, according to definition, limit extends to 10 minus left hand limit, that is equal to right hand limit, x tends to 10 plus f of x, that is also equal to f of 10. So that implies limit h tends to formula 0, f of 10 minus h, that is equal to limit h tends to 0, 10 plus h, that is equal to f of 10. You come here. So that implies, or by implies, h tends to 0. Here, what does it mean? X less than 10. Where is x less than 10? Here is. Means it means a into, in the case of x we are writing 10 minus h plus b. So that is equal to greater than 10. It is constant 21. That is equal to, in the case of x equal to 10, it is also defined same 21. So it is 21. So that implies it is nothing but a limit h tends to 0. So a into 10 minus 0 plus b, that is equal to 21. So that y implies 10 a plus b equal to 21. So let it be equation number 2. So therefore first equation 2a plus b, 2a plus b equal to 5. It is first equation. Second equation 10a plus b, that is equal to 21. So you can solve by any way for equation number 1 and number 2 for the values of a comma b. So therefore from 1 and 2, from 1 and 2, we have clearly a equal to 2 and b equal to 1. So you can solve these two equations 1 and 2 by substitution method or elimination method or by cross multiplication method. You can follow any method for the values of a comma b. So therefore clearly a equal to 2, b equal to 1. 2 to the 4 plus 1 5. Okay, it is satisfied. 10 into 2 20, 20 plus 1 21. It is satisfied. So clearly a equal to 2 and b equal to 1. Therefore for a equal to 2 and b equal to 1, the given function is continuous at the points x equal to 2 and x equal to 10. Show that first f of x equal to cos of x square and f of x equal to sin of modulus of x are continuous functions. Already I said about the continuity of a composite function. So I wish to recall once again that definition. For example, f of x is continuous at x equal to a and g of x is continuous at f of a. Then g circle f of x, that is g of f of x is also continuous at x equal to a. So it is called the composite. It is called the composite function. It is called the composite function. So the composite function is also continuous at the same point. Okay. So first one, capital, say it is capital f of x. It is also say capital f of x. Given that, first question, given that capital f of x equal to something cos of x square. Actually it is small question. Here let first function f of x, let f of x equal to x square. Actually f of x equal to x square means it is a polynomial. It is a polynomial and it is always continuous, always continuous for all x belongs to capital R. Already I said in the standard results. Okay, next and let z of x equal to cos x. Actually it is a trigonometric function. It is a trigonometric function. Every trigonometric function is continuous at their respective domains. I said the standard. I said in the standard results. Okay, trigonometric function, and it is always continuous for all x belongs to capital R, because capital R is the domain of the cos function. So therefore G circle f of x is equal to z of f of x, that is equal to z of fx means x square, that is equal to g means cos. So cos of, instead of x we are writing x square, is also continuous for all x belongs to capital R. Therefore cos of x square, that is capital f of x, is continuous for all x belongs to capital R. Over. Next question. Second question. Capital f of x equal to sine of modulus of x. Similarly, let small f of x is equal to modulus of x. Already I said mod x into mod x plus or minus mod x are always continuous functions. So is continuous function for all x belongs to capital R, and z of x equal to, let us take trigonometric function sin x, is always continuous for all x belongs to capital R, because capital R, real number set, is the domain of sin x. Every trigonometric function is a continuous function at their respective domains. Okay, so therefore thus z circle f of x, that is z of f of x, that is z of f of x means modulus of x, that is equal to sine of modulus of x, is also continuous for all x belongs to capital R. So therefore thus both the functions are always continuous functions for all x belongs to capital R. Wow. Next question. Show that capital f of x, let us write capital f of x. Capital f of x equal to modulus of cos x is a continuous function. This is very important concept for competitive track. Actually, already I said in the synopsis, if f of x is continuous function, then modulus of f of x is also continuous function. That is simply f of x is continuous implies modulus of f of x is also continuous. This is the formula. Okay. Here let small f of x is equal to trigonometric function cos x. So clearly f of x is continuous at x belongs to capital R, because every trigonometric function is continuous at their respective domains, means cos x domain capital R. So therefore at every real number cos x is continuous. So therefore that is implied modulus of f of x is also continuous at the same points x belongs to capital R. That implies modulus of, what is f of x? Cos x. Modulus of cos x is continuous for all x belongs to capital R. Hence the problem. Question. Fx is defined as x square into sine of 1 by x if x not equal to 0, and if x equal to 0 then it is defined as 0. So we have to examine whether it is a continuous function or not. Here only one number is appearing, it is 0. It is 0. So x not equal to 0 means just this one is a deleted neighborhood area of 0, and it is also a deleted neighborhood area of 0. Actually to understand easily I am taking this much of gap. Actually it is not that kind of gap is there. Deleted neighborhood means just if it is 0, x equal to 0 means will be like that here or here, just within one hair gap is there. Okay. It is called deleted neighborhood area. Next, x not equal to 0. This is x not equal to 0. This is also x not equal to 0 area. It is defined as x square into sine of 1 by x. It is also x square into sine of 1 by x. Remember, it is not discrete function because no different intervals are there. At x equal to 0 means here exactly at x equal to 0 it is defined as 0. So therefore that is f of at x equal to 0 it is defined as 0. So it is not a discrete function. Therefore we are following first definition. What is the first definition? Limit x tends to a, f of x is equal to f of a, then by implies f of x is continuous at x equal to a. This is the main concept. So we are not going through left hand limit and right hand limit. We are not using that method because once again it is not discrete function. X at x equal to a so and so, when x not equal to a so and so. This kind of functions are not discrete functions. Remember. Okay. Next, f of 0 equal to 0. But 1 minute, let it be capital F of x. But one important, one beautiful rule is there. What is that? Limit x tends to a, f of x equal to something 0. If limit x tends to a, f of x equal to 0, and as x tends to a, z of x is only bounded function, then limit x tends to a, f of x into g of x equal to 0. It is just as in real number set 0 into any other than 0 real number equal to 0, like that. Means if the product of two numbers is 0, then need not be equal to both are 0. It is enough to equal to 0 only one number. Understand? In the same sense, limit extends to a, f of x into g of x equal to 0. Once again, if the product of the two numbers are here, for example, 0 into 4 is equal to 0. 7 into 0 is also equal to 0. So therefore, if the product of two numbers is 0, then it is enough to equal to 0 only one number. Need not be equal to both numbers are 0. Like that. Okay. That's why only limit extends to a, f of x equals to 0. Then what about g of x? It is enough to be bounded function. Okay, 1 minute. Here. So this is f of x. Let small f of x is equal to x square. So therefore, limit x tends to a means here we are discussing at x equal to 0. 0. F of x equal to 0 square means clearly 0. Therefore, limit extends to 0. F of x equals to 0. Just like that. Next. Actually, sine of 1 by x means sine of anything is bounded function as x tends to 0. Don't say, sir, put x equal to 0, 1 by 0 infinity, sin infinity not defined. This is not right way of thinking like that. Okay, this is the wrong way. Don't think like that. Okay, actually graphical meaning will be like that. Graph will be like that. It is the maximum value of sin theta plus 1, minimum value it is minus 1, it is minus 1, it is minus 1, so as x tends to 0 it is infinity, na? X tends to 0 means it will be like that. Just like that, maximum value, it will oscillate like that, This is y-axis, x-axis, like that, plus 1, minus 1. It will be bounded between plus 1 and minus 1. As x tends to 0, it is infinity. Means it will touch at infinity. So this is sine of 1 by x graph. So therefore, let it be g of x. So therefore, limit x tends to 0, f of x equals to 0, and as x tends to 0, g of x is bounded function. Bounded function means it has upper bound and lower bound. Lower bound is minus 1, upper bound is plus 1. Okay, so therefore, according to that concept, limit x tends to 0, f of x into g of x, that is also equal to 0 because it is 0. So that implies limit x tends to 0. What is f of x? X square. What is g of x? Sine of 1 by x. It is 0. Hence the problem. 1 minute. So, basics are over. In this topic, first you will have to able you are able to find whether the given function is ordinary function or special function. Once again, ordinary function, how can we find the given function is an ordinary function? All trigonometric functions, inverse functions, polynomials, just like that. And that to be at x equals to, you come here, at x equal to so and so point only, just like that. At x equal to a, it is defined as something one value, fixed value. At x not equal to a, something function. This kind of functions are ordinary functions for which we are approaching only this definition particularly, but this case is very different. That's why for this question I approached through this concept. It is out of question. Next, special function. If a mod is there, modulus function, mod is there, box is there. Next, discrete means once again f of x equal to so and so if x is less than or equal to a, and so if x is greater than a, just like that. How many intervals are there? It is out of question. In different intervals, it is defined as different. This kind of functions are discrete function. And lastly, e power 1 by x minus e power minus 1 by x divided by e power 1 by x plus e power minus 1 by x. This kind of functions. So 1, 2, 3, 4. 4 kinds of functions are said to be special functions. For which 4 kinds of functions we have to discuss left hand limit and right hand limit and f of a value. Once again, first you determine whether it is an ordinary function or special function. If it is an ordinary function, you go through the first definition. If it is a special function, means any function out of these 4, then you find first left hand limit and right hand limit and f of x. And if 3 values are same, then we can say that f of x is continuous at x equal to a. Otherwise, any one of the conditions or any one of the value is different, then we can say that bluntly f of x is a discontinuous function at x equal to a. No confusion. It is very clear. Only 2 kinds out of ordinary function or special function. Later, you must by heart this formula. It is compulsory. Left hand limit at x equals to a, once again, means limit x tends to a minus f of x, that is equal to, it is the notation. So formula, limit h tends to 0, f of a minus h. So how can we write this value? First you come here, x tends to a minus stands for less than a. So in this area, what is f of x? Let us find from the question. After that, write here itself a minus h. Later copy here and put h equal to 0 directly. Then we are obtaining so and so value. Next, right hand limit at x equals to a. So first notation, x tends to a plus f of x. So formula, limit h tends to 0, f of a plus h. So how can we find this value? Before that, you find this area. It is what? X greater than a. In this area, what is f of x? Find out from the question. After that, write the value there itself, f of a plus h something, and copy here and put h equal to 0 and obtain the value. Later, don't forget to find f of a value. Some students, most of the students, 50% students are going to forget to find the value of f of x. Bluntly they are saying that left hand limit equal to right hand limit, therefore f of x is continuous at x equal to a. This is the wrong way. You besides that, you have to find f of a. So therefore, right definition, if left hand limit equal to right hand limit equal to f of a, then only it is continuous at x equal to a. Otherwise it is not continuous. Therefore find 3 values f of a. So follow this procedure. All the best.